Question states you have two charges, a positive and a negative. They're both the same magnitude of charge. The magnitude is 3 times 10 to the minus 9 coulombs. The distance between the two charges is 0.12 meters. So each is halfway, half that distance to the origin. This is 0.06 meters. This is 0.06 meters. What's the net electric field at the origin due to those two charges? Okay, and we're all over the place. The answer is not 9. The answer is not 9. Sorry, the answer is 5. The answer is 5. Save yourself time and effort by actually drawing the direction of the fields first, right? You're going to find over and over again in this course that drawing a picture is always the first step you want to do, and it's always going to help. Superposition says the electric field of the positive charge should be pointing in what direction? That way. The electric field of the negative charge should be pointing in what direction? That way. They're not going to cancel out because they're oppositely signed charges, and so the fields due to those two charges point in the same direction at that location. Okay? Now, can you use the dipole formulas to calculate that field? Why not? Yeah, S is the distance is much smaller than S, not much greater than S, right? These formulas are only for the approximation that the distance is much bigger than S. Well, the distance here is S over 2, right? I mean, or from the origin, it's 0, right? So you can't use the dipoles. You just have to calculate what the electric field is. And you know the field is going to be the same for each. So if you do it for one, you can just double it, right? It's the same distance and it's the same magnitude of charge. So what is that magnitude? It's 1 over 4 pi epsilon 0 Q over S over 2 squared. So that's 9 times 10 to the 9th. Oh, did we not? I forgot to put the constant up. Someone should have yelled at me for not putting the constant up. I apologize for that. What was the charge? 3 times 10 to the minus 9. And divided by 0.06 squared. So that is, 27 over 0.06 squared. I believe that gives you 7,500, right? And then twice that would be 1.5 times 10 to the 4th, right? We can check that. I think that's 7,500. Double check this. 7,500 newtons per coulomb. And then 2 times that, 7,500. Okay, thanks. There you go.